Hello, everybody. So today we're going to be talking about properties to solve addition and multiplication problems. We are on lesson 1.3 on page 13 of the 5th grade Go Math textbook. And our essential question that we should be able to answer at the end of this lesson is, how can you use properties of operations to solve problems? Okay, so let's get started. You can use the properties of operations to help you evaluate numerical expressions more easily. So there's three properties of addition that we should know. Okay, we've been talking about these different types of properties since 3rd grade. So this is our 3rd time around. And commutative property of addition. Well, that says that if the order of addends changes, the sum stays the same. So whether we start with 12 and add 7 to it, or we start with 7 and add 12 to the 7, we're still going to get the same sum of 19. So commutative property, if the order of the addends change, the sum will stay the same. The associative property of addition, if the grouping of the addends changes, the sum stays the same. So commutative was the order, associative is the grouping. So here we see 5 plus 8 plus 14. On the other side of the equal sign, we see that it's 5 plus 8 plus 14. So the addends are in exactly the same order, but you notice the grouping symbols are different. On the left-hand side, they're grouping 8 and 14. On the right-hand side, it's been changed to group the 5 and the 18. Okay, so in the left side, we would add 8 and 14 first and get 22. And then add 5 more, we'd get 27. On the right-hand side, we have to add 5 plus 8 first. We would get 13. And if you add 14 more to 13, we'd still get 27. So it doesn't matter how the addends are grouped, the sum will stay the same. And then the identity property of addition says that the sum of any number and 0 is that number. So anytime you add 0 to an addend, to another addend, you get that number, that other addend. Okay, so properties of multiplication. So commutative property of multiplication, basically the same idea as commutative property of addition. And it says that the order of the factors changes, the product will stay the same. So I could have 4 sets of 9, which would be the same as saying 9 sets of 4. So 4 times 9 is 36, and 9 times 4 is 36. Doesn't change the product. So the order of the factors changes in the commutative property. In the associative property, just like in the associative property of addition, the grouping of the factors changes. The product will stay the same. So here again, we see the factor 11 times the product of 3 times 6. On the right-hand side, we see that 11 times 3, the product of 11 and 3 times the factor 6. So all they did was, the factors are in the same exact order, 11, 3, 6, 11, 3, 6. They're just, the grouping of them are different. On the left-hand side, they're grouping the factors 3 and 6. On the right-hand side, they group the 11 and the 3 first. Okay, so you would still get the same product because there's the same factors. Okay, it's just changing the order in which they're being multiplied, or how they're being grouped to be multiplied. And then the identity property of multiplication is the product of any number and 1 is that number. So it's related to the identity property of addition in the sense that the sum of any number and 0 is that number. And in multiplication, it's any number times 1 is that number. So in this example, they're given 4 times 1, it's 4. It could be a billion times 1. It'd still be a billion. Okay. All right, so let's look at some examples. So the unlock the problem for this lesson. The table shows the number of bones in several parts of the human body. What is the total number of bones in the ribs, the skull, and the spine? What is the total number of bones in the ribs, the skull, and the spine? So here's our table. We have 4 different body parts and the number of bones in those body parts. And so we want the ribs, the skull, and the spine. All right, and so to find the sum of addends using mental math, you can use the commutative and associative properties. So here we just have 24 plus 28 plus 26. All right, so let's look at these numbers a little more closely rather than just quickly starting to add. Do we notice 2 numbers that are compatible in the sense that when I add them together, I get another number that ends in 0? Well, 8 and 4, that's not going to end in a 0, right? That's 12. But 6 and 4 is a 10. So why don't we switch the order of the 28 and the 24 so that the 24 will be added with the 26? Okay, so all I'm doing is changing the order of the 28 and the 24. Okay, the addends 28 and 24 are switching places. That's based on the commutative property. Okay, so that allows us to reorder. Now let's use the associative property to group them. Okay, so right now, if I didn't have any grouping symbols, I'm supposed to add 28 plus 24. But the reason I moved the 24 was because I wanted to add it to the 26, because that's an easier number. Okay, because 6 and 4 makes a 10. So I want to group the addends 26 and 24. So we're going to put parentheses around them, because we know by order of operations that we have to do parentheses first. So I want to add 24 and 26 first. All right, so what is 26 and 24? Well, that's 50. 6 plus 4 is 10, and 2 tens and 2 tens is 4 tens, plus 3 group 10, 5 tens. So what is 50 plus 78? Well, that's easy. 50, 60, 78. So there are 78 bones in the ribs, the skull, and the spine. Okay, so again, the reason we want to use commutative property is to get 2 numbers that are easier to add in our head. Okay, and 24 and 26, because 6 and 4 is 10, that's easy to add. Okay, and it's also going to make it much easier at the end to add, because it does end in a 0. All right, now, distributive property. Okay, so let's look at this closely. Multiplying a sum, so multiplying an addition number by a number is the same as multiplying each addend by the number and then adding the products. So let's see if we can break that down and look at it here. Multiplying a sum, so the sum is 7 plus 9, by a number is the same as multiplying each addend by the number. So we notice that each of the addends, 7 and 9, is being multiplied by 5. Okay, so we could say 5 times 16 and solve it that way. But using the distributive property says that, well, that's the same as saying 5 times 7 plus 5 times 9. So the distributive property can also be used with multiplication and subtraction. For example, 2 times 10 minus 8. Well, I'd multiply 2 times 10 and then subtract the product of 2 and 8. Okay, so that's the same thing. We're still multiplying by this factor of 2. We're using the 2 numbers that we're subtracting, the 10 and the 8. Okay, and the only difference between when it has a sum and when it is subtraction is that in between, the one that has the sum, multiplying by the sum, we're going to add the 2 different products. In the one that has the subtraction, we're going to subtract the 2 products. So let's practice some of this. All right, so use the distributive property to find the product. One way is to use addition. 8 times 59 equals 8 times what? Well, we could just go ahead and multiply using regrouping and do 59 times 8. But I can also use the distributive property to break up the 59 into a number times the sum, or the sum of a number times a factor or number, is the same as multiplying that number by each addend. So we have 8 times 59. All we did was break up the 59 into 8 times 50 and 8 times 9. Okay, so 8 times 50, we should be able to do that in our head. It's 8 times 5 tens. 8 times 5 tens. 8 times 5 is 40. So 40 tens is 400. And 8 times 9 is 72. Now, we shouldn't at this point in 5th grade have to use the strategies we learned in 3rd and 4th grade for figuring out what 8 times 9 is. Okay, we really should have those memorized at this point. We should know 8 times 9 is 72. Okay, all right, and then 400 plus 72, that's easy to do, right? It's just 472. But I could also, I see that 59, that's really close to 60, right? Why don't I change the 59 to 60 and use subtraction? So we could say 8 times 60 take away 1. What's 60 take away 1? 59. So I didn't change the value. I just made a number that's going to be easier to multiply. Okay, so we're going to say 8 times 60 minus 8 times 1. Okay, so we have to multiply the number 8 by both of the numbers in the subtraction problem. So 8 times 60 and 8 times 1. And we're going to subtract them. We're going to subtract the products of those two problems. 8 times 60. Well, 8 times 6 tens. 8 times 6 is 48. So we have 480. 48 tens is 480. Minus 8 times 1. 8 times 1 is 8. Well, what's 10 take away 8? 2, right? So 480 take away 8 is 472. So you notice we got the same answer using the distributive property, either using addition and subtraction. So either way works. Now, how about example 2? Complete the equation and tell which property you used. So 23 times something is 23. Well, 23 times 1 is 23. What property tells us that when we multiply a number by 1, the product is that number? That's the identity property. Okay, identity property of multiplication. And in B, 47 times 15 equals 15 times what? So I notice that here, the factor 15 comes second. So they're changing the order. Now it comes first. So for it to be equal, it has to be 15 times 47 because we got to keep the factors the same. So the property that tells us we can do that is the commutative property of multiplication. All right, so let's work on some share and show problems. So on numbers 1 through 4, in number 1, we're going to use properties to find the product of 4 times 23 times 25. In the numbers 2 through 4, we're going to use properties to find the sum or the product. All right, so on number 1, let's look at this problem. We start with 4 times 23 times 25. But I see that they switched the order and they want to start with 23. So I see the 23 and I see the 25. The factor that's missing is the 4. Now, what property tells us we can switch the order of the factors without changing the product? That's commutative property. Now, can you think of a reason why you'd want to switch the order of the 23 and the 4? Well, I don't think it can be that we want to multiply 23 and 4, because that's the same thing. So why would I change that? But what is 4 times 25? That's pretty easy to do, right? It's definitely a lot easier than 23 times 25. Okay, so you notice that we have the 23 outside of the parentheses. And so inside, we want 4 and 25. So we're grouping 4 and 25 because we want to do that first because that's easy to do in our head. And the property that tells us that the grouping of the factors doesn't change the product is the associative property. So rather than multiplying 23 and 4, I want to multiply 4 and 25. What is 4 times 25? 4 quarters, right? What is 4 quarters? 100. All right. Well, now we have 23 hundredths. Okay. Simple enough. Okay. Now, number 2, use properties to find the sum or the product. 89 plus 27 plus 11. Now, of course, I can just add that. I could go in that order because the order of operations says that when there's only addition left in a problem, you just add left to right. But when I look closer at the numbers, I see that if I add 9 ones to 1 1, that gives me a 10. Well, that's going to give me, that would be much easier to add. So why don't we do this? Why don't we switch the order of the 27 and the 11? What property lets us do that? Commutative property, right? Of addition. All right, now I want to group 89 plus 11 and then add the 27. 89 plus 11 is 100. 9 plus 1 is 10. Regroup that, so we'd have 110 plus 8 tens and another 110. That's 10 tens, which is 100. And then 100 plus 27, 127. What step did we allow us to group 89 and 11? The associative property of addition. All right, number 3, 9 times 52. Well, can you think of an easier way that we could, rather than going just 9 times 52, we could multiply that and use regrouping, no problem, okay? But we're trying to use some of our math properties to make this actually easier to do. Well, and I think we can use the distributive property in this one to make this a lot easier. So if we change the 52 into 9 times 50 plus 2, okay, you see what I did? All I did was take the 52 and say, well, let's break that up into 50 and 2. And so now the distributive property tells us that the sum of a number times the product is the same as that number times each of the addends. So 9 times 50 plus 9 times 2. So take the number that we're multiplying by and multiply by each of the addends. 9 times 50 plus 9 times 2. Well, 9 times 50 is 450. 9 times 5 is 45, so we have 45 tenths. 9 plus 8, 9 times 2 is 18. So 450 plus 18. 50 and 18 more, 68. 468. And so this is being solved using distributive property. Okay. Now number 4, 107 plus 0 plus 39 plus 13. Okay, so which ones do you see would be the easiest to add? Well, I think I'd like to get the 13 next to the 107. So that would be 120. So how could we do that? So I can't just change the order of the 39 and the 13, right? Because that just puts us at 13 plus 0. Oh, but maybe that's not a bad idea. 107 plus 0 plus 13 plus 39. Okay, so that's commutative property, right? So I'm going to abbreviate that just commutative there. Now, I want to group the 0 and the 13. Which property allows us to group addends without changing the sum? The associative property. I'm not going to abbreviate that one. The associative property. That leaves me 107 plus 13 plus 39. Okay, let's group 107 plus 13. Associative. That leaves me 120 plus 39. 120 plus 39 is 159. You also could have used the identity property of 0, right? 107 plus 0. And then that would have left us 107 plus 13 plus 39. So multiple ways you can solve it. Okay. All right, number 5. So complete the equation and tell which property you used. So this basic setup, when I see something like that, that's usually a clue that we're going to be using the distributive property, because we have the sum of numbers times a number. And then I see that the 9 is being multiplied by both of the addends. So the missing addend is 30. Okay, they already had 9 times 7. I still need to multiply the 9 times the 30. All right, so this is the distributive property. That would be used to complete the equation. If we were to solve that, 9 times 30 would be 27 tenths plus 63. and we get 333. It just said complete the equation, though. So I completed the equation. We really don't need to find the answer on that one. All right, how about number 6? 0 plus something is 47. Well, it's got to be 47, right? Any number plus 0 is that number. And that's the identity property of addition. All right, number 7. Copy and solve. Use properties to find the sum or the product. All right, so number 7. 3 times 78. Well, there's only 2 factors, so commutative property is not going to really help me. Associative property wouldn't make sense. There is an identity property in that problem because we're not multiplying by 1. So the only property that's really available to me to use to make this problem simpler is the distributive property. And so what we would try to do is break up the 78 into 2 add-ins that will be easier to multiply. So 78 is the same as saying 70 plus 8. Or we could say 3 times 80 minus 2. Okay, because 78 is kind of close to 80, right? So either way will work. We can use addition in the distributive property, or we can use subtraction in the distributive property. All right, so 3 times 70 plus 3 times 8. Okay, so again, the factor times each of the add-ins. Okay, or multiply the number times each of the numbers in the subtraction problem. 3 times 80 minus 3 times 2. Okay. All right, so now 3 times 7. 3 times 7 is 21. 21 tens is 210. 3 times 8 is 24. So that gives me a sum of 234. 3 times 80 is 24 tens minus 6. Well, what's 40 take away 6? Well, 10 take away 6 is 4, so 234. So either way. All right, now number 8. Number 8 says 4. It has the factors 4, 60, and 5. So 4 times 60 times 5. Now, those are actually all pretty straightforward, nice numbers, right? Do we want to say 4 times 60 and then take that product and multiply by 5? Or would it be easier to go 60 times 5 and multiply that product by 4? Or does it make more sense to switch the order of the 60 and the 5 to get 4 times 5 times 60? Well, I think, and again, there's multiple ways of doing this, but I think I'm going to start with the associative property. Okay, I want to multiply 60 times 5. Because what is 5 sets of 60? Well, 5 sets of 6 tens is 30 tens, and 30 tens is 300. So I'm using the associative property of multiplication to group 60 and 5. And now we have 4 sets of 300. Well, 4 times 3 is 12 hundredths. So 1,200. Okay, number 9. We have the sum of 21 and 25 and 39 and 5. Okay, so we have 4 add-ins. Are there any add-ins that would be easier to add? Well, I see the 1 and the 9. That would give me a 10, right? So that would be good. And 25 on 25 and 5, that's easy to do. That's 30. So let's switch the order of the 39 and the 25. What allows you to do that? The commutative property. And again, the reason we want to use commutative property is to put 2 add-ins close together that are easy to add in our head. Okay, so we want to switch the order of those 2 numbers. Commutative property of addition. All right, now let's group 21 plus 39 plus 25 and 5. That's the associative property. All right, 9 and 1 is 10. Regroup that as an extra 10. So we'd have 3 tens plus 2 tens is 5 tens. Plus the regroup 10 is 6 tens. 25 and 5, 30. Well, 60 and 30 is easy to do. That's 90. Okay. All right, number 10. Complete the equation and tell which property you used. All right, so let's again look very closely. So we have an equal sign, so that's why we're having an equation. We have 11 plus the sum of 19 plus 6. And then I see the parentheses now includes the 11, and the 6 is on the outside. So I have to use the same add-ins, so that has to be a 19. So what did they do? They didn't change the order of the add-ins. They just changed how they're grouped. If you change how things are grouped, you use the grouping property, which is the associative property. Okay? The associative property of addition. All right, number 11, we have the sum of 25 and 14 on one side, and on the other side, we have some number plus 25. Well, in order for these to be equal, there's only 2 add-ins on the left-hand side, and one of them is the 25 on the right-hand side, so the other one's got to be the 14. So what property allows you to switch the order? The commutative property. All right, number 12. Show how you can use the distributive property to rewrite and find 32 times 6 times 32 times 4. Well, remember that a number times the sum of two numbers is the same as that number times each of the addends. So we can rewrite 32 times 6 plus 32 times 4 as 32 times 6 plus 4. Now, why would we want to do that? Well, 32 times 6, that's actually not very easy to do in our head. And then we'd have to add 32 times 4. So that's not an actually easier way to do it. But 6 plus 4, that's 10. It's easy to multiply a number by 10. So 32 times 10 is easy. 32 times 1, 10. 32 times 1 is 32. So we have 32 tens, or 320. Okay, number 16. Sorry, page 16, number 13. All right. Three friends' meals at a restaurant cost $13, $14, and $11. Use parentheses to write two different expressions to show how much the friends spent in all. Which property does your pair of expressions demonstrate? All right, so 13. So we have 13 plus 14 plus 11 is equal to 13 plus 14 plus 11. Okay, so we're using the same numbers, right? Same order. How can we use parentheses to make these two different expressions? Well, we could say 13 plus 14 plus 11, or we can say 13 plus the sum of 14 and 11. So what property does that show? That shows the associative property of addition. All right, what's our answer? Well, 14 and 11 is 25. 25 plus 10 is 35. Plus 3 more ones, 38. $38. All right, 14. Use reasoning. Jacob's designing an aquarium for a doctor's office. He plans to buy 6 red blonde guppies, 1 blue neon guppy, and 1 yellow guppy. The table shows the price list for the guppies. How much will the guppies for the aquarium cost? All right, so here are our fancy guppy prices. Blue neon, 11. The red blonde guppy is 22. And the yellow guppy is 19. All right, but now it says 6 blonde, red blonde guppies. So 6 times 22 plus the 1 blue neon plus the 1 yellow guppy. Okay, so on the 1 times 11 and the 1 times 19, there's only one of those fish. So couldn't we just simplify that by saying 11 and 19? Sure we could. Okay. All right. So is 11 and 19 friendly numbers to multiply? Or to add? Sure. 11 and 19 is 30. So we have 6 red blonde guppies at $22. And we have 11 plus 19, which is 30. So we'd be using the associative property to groups 11 and 19 and then the multiplication problem. So now 6 times 22 plus 30. Well, let's break up the 20 into 6 times 20 plus 6 times 2 plus 30. What did we use? We're using the distributive property. To make 6 times 22 easier to multiply in our head. And 6 sets of 2 tens is 120 plus 6 times 2, which is 12, plus 30. 120 plus 12 is 132 plus 30, $162. All right, number 15. Sylvia bought 8 tickets to a concert. Each ticket cost $18. To find the total cost in dollars, she added the product 8 times 10 to the product 8 times 8 for a total of 144. Which property did she use? So let's see. So she bought 8 tickets at $18. Says she figured it out by going 8 times 10 plus 8 times 8 equals 144. So what property did she use? She broke up the 18 into 2 smaller add-ins and multiplied by the 8. That's distributive property. All right, number 16. Julie wrote 15 take away 6 minus 3 equals 15 take away 6 minus 3. Is Julie's equation sense or nonsense? Well, 15 take away 6 is 9, and 9 take away 3 is 6. 15 take away 3 is 12. So her equation must be nonsense. Because remember, you have to do what's in parentheses first. So in this case, 15 take away 6 minus 3 is 9 take away 3, which is 6. 15 take away the difference of 6 and 3 would be 15 take away 3, which is equal to 12. Equations do not equal each other. The associative property does not work for subtraction. All right, how about 17? Find the property that each equation shows. Okay, so carefully look at each side, right? 14 times the product of 4 and 9. The product of 14 and 4 times 9. So I see that the factors are in the same exact order. 14, 4, 9. 14, 4, 9. The only difference is how they were grouped. On the left-hand side of the equation, the 4 and the 9 are grouped. On the right-hand side, the 14 and the 4 are grouped. So how they're grouped, that's the grouping property or the associative property of multiplication. 1 times 3 is the same as 3 times 1. So I have the same factors, but they're not in the same order. Here, 1 comes first. On the right-hand side, the 3 comes first. So that's just commutative property. They just switched the order. But that is true. They did just change the order. But what they're also 3 times 1, any number times 1 is actually showing the identity property. And then 7 times 3 equals 3 times 7. That is just, they're just switching the order, okay? So I probably could have said that the 1 times 3, 3 times 1 is showing commutative property, but it is also showing the identity property. All right, but 7 times 3 equals 7 times 3 times 7 is commutative. Okay. All right, so that's it for our review of properties. In our next lesson, we're going to be talking about the powers of 10 and the exponents. So until then, I will see you soon.